Good evening and once again welcome to my YouTube channel, Pearson Excel International Maths by Mr. Kamotho. And we are going to proceed with our topic, or rather subtopic introduced yesterday, which is implicit differentiation. Implicit differentiation, and we are going to dwell so much on its application. And we are told that given that 4xy squared plus 2x squared over y is equals to 10, find dy dx at the point 1, 1. And if you examine our function, it has mixed variables, x, y squared in the same term, x and y in the same term, and it becomes very difficult to express one variable in terms of the other. That means making y the subject of the formula, which is not easy, and therefore we should then differentiate them the way they are, and this is what we call implicit differentiation. The only thing that we must remember during implicit differentiation is when we are differentiating this function and then we get to a variable y, and we are supposed to differentiate with respect to x, please remember to insert or include dy dx as required by the chain rule. And therefore, before we do anything, we must rewrite it in a format that is going to be integrated or differentiated easily, which is 4xy squared plus 6x squared y raised to power minus 1 is equals to 10. At this point, we need to talk about dy dx. And for this particular term, let us first of all differentiate with respect to x. And you can see x is to power 1, and everything else around x is regarded or considered to be the coefficient of x. And therefore, differentiating with this one with respect to x, then we have 4y squared x raised to power 0, and it remains that way. We differentiate this y squared with respect to x. We must remember that the power of y is 2, and then 2 times the rest of anything that is surrounding y is considered to be the coefficient of y, and 2 times 4x becomes plus 8x y raised to power 1 dy dx. Remember that. We must now be able to differentiate x squared, and anything around x squared is the coefficient of x, which means 2 times 6, which is 12, y raised to power minus 1 of x raised to power 1, because x now index reduces by 1, and then we go to y raised to power negative 1, and everything else becomes the coefficient of y raised to power negative 1. So the differential of that is minus 6x squared y raised to power minus 2. And again, remember to introduce dy dx, of course, is equals to differential of 10, which is 0. Having said that, we may now be interested to rewrite this function in a more clear way, which is going to be 4y squared plus 8xy dy dx plus 12x over y. You realize that y raised to power negative 1 is 12x over y minus 6x squared over y squared, and again dy dx is equals to 0. At that point, we can easily substitute because we have y and x. Substitute x is equals to 1 and y is equals to 1, and we have 4. 1 squared is 1, plus 8 times 1 times 1, plus 8 dy dx plus 12 over 1, 12 times 1 over 1 minus minus 6 dy dx is equals to 0. And one thing we must remember is that this is 4 plus 12, which is 16. 8 dy dx minus 6 dy dx is 2 dy dx, which is equals to 0. And of course, we are supposed to make dy dx the subject of the formula, and therefore 2 dy dx is equals to minus 16. And of course, if you divide both sides by 2 and by 2, you realize that our dy dx is simply minus 8. And that is what we needed to realize. Of most importance is the implicit differentiation, whereby we differentiate the variable y with respect to x, not the function y, but the variable y with respect to x, and that is when we will never leave behind dy dx in both aspects. But anyway, that is the end of the question, and you're going to look at another question to familiarize further with this particular approach. All right,